Hello everybody. So in this video we're going to be looking at prime numbers. By the way, we are on unit 1, fundamentals, on page number 17. Okay, so you can go ahead and turn there. So we're going to be looking at prime numbers. And what is a prime number? By definition, a prime number is a number only divisible by themselves in 1. Okay, so what does this mean over here? So some of the notable prime numbers, the first ones is 2, 3, 5, 7. Okay, so 2, 3, 5, 7, 11, 13, 17, 19, and 23 are our prime numbers. These are very important because prime numbers can multiply to form any number. So for example, 24 is secretly 2 cubed times 3, right? So if we remember, that's 8 times 3. So in other words, this means that 2 to the power of 3 is going to be 8 times 3, which is 24. So this is actually called the fundamental theorem of algebra. It's not in the course, but it's important to understand why we like prime numbers. Okay, and they are whole numbers. 14 is not a prime number. So in other words, this number is divisible by 1, 2, 7, and 14. So thus 14 is a composite number. It's not a prime number. Okay? And just a quick note, the smallest prime number is 2, not 1. Okay? So one of the important terms over here, or one of the important things we're going to be talking about, and we're going to go ahead and skip to actually, no, we'll go ahead and stay on page 19 here. So we're going to look at prime factorization using a factor tree. Okay, so our goal is to find all the prime factors of a given number, and we're going to do this over here using these trees over here. So it says finding all the prime factors of a given number is useful when doing operations with fractions. Excuse me, and extends to operations with rational functions later. Okay, so when we do a factor tree, what do? We basically deconstruct a number in factors, right? So 24 is 2 times 12. When you're done with that, you circle it and you continue. 12 is 3 times 4, circle it. 4, 2 times 2. And when you're done, you write it as 24 is 2 times 2 times 2 times 3, or 3 cubed times 3 here. In particular, the word factor over here, this is basically a number that multiplies to make up another number. So an example, 6 is a factor of 24 because 6 times 4 is 24. Okay? Another example, let's say 12 is a factor of 144 because 12 times 12 is 144. Okay? So this is what it is to be a factor. Okay? Versus if we look at a multiple, right? So what is a multiple? So a multiple basically is a multiple is any number that is created by multiplying that number by an integer. Okay? So what does this mean? So examples. Let's do an example here. So example. So I'm going to do the multiples of 3. And so what you do here is very simple. You go ahead and first you want to set up the natural numbers. So above 3, write 1, 2, 3, 4, 5, 6, dot, dot, dot. And so what are the multiples of 3? You multiply here. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. Okay? 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. Dot, dot, dot. So we say, so the multiples of 3 are, and we make a list. What were they? 3, 6, 9, 12, 15, 18, etc. So these are the multiples. Okay? So later on, we're going to talk about the least common multiple and the greatest common multiple here. But we need to make sure that we understand the definition of a multiple and also how it's used compared to the definition of a factor over here.